So what we introduced last time was the idea of starting to use probability as part of our curve, because probability typically ranges from 0 to 1. And then since the area under the curve is bounded by 1, what we're going to start to do is think about the area under the curve in terms of probability. And the way that I wanted to make this transition was talking about sample means. Because what we've been doing so far is treating our data as the data and not really looking outside of it, not trying to relate it to the population, but we're just saying, here's a set of numbers, right? Here's 10 numbers. Calculate everything for it. But again, we're not going to run into too many situations as social scientists where we have all of the numbers. We're never going to run into that. It takes a little bit of a twist in logic to say that you have. So let's say you can study the states, and you can say, I have all 50 states. Boom, I have the population. Do you have all 50 states for every year? Well, no. All right, then you have a sample. Your sample is the year out of all of the years. Okay. When we do elections, a lot of times we'll see numbers, and we were just chatting about this, right? This poll says this. Well, we have to remember that a poll is a sample from a larger population. So let's say a candidate is said to have 47% support. Well, that number, 47, is from the sample. It's from the 1,500 people that were asked, right? It is the sample mean. But we know that there are going to be more than 1,500 people that are going to vote in the election. Right? There's going to be like 100 million people voting in the election. So what's the chance that our sample mean is close to the mean, the population mean? When you see discussions of the polls, you'll notice that there's a lot of variability in how people regard the polls. Because when you're doing a poll, a lot of the methodology behind it is really important. So when I'm surveying people, who is it that I should survey or should not survey when I'm surveying people in for their choice? Is there any way that I should narrow it down or make it bigger in who I survey? So if I'm surveying people in the United States about their presidential election choice, who shouldn't I survey? No, you're just talking now. Who should I not ask?
People who don't live in America.
Okay, we can narrow that down. You're wrong. There, we're getting closer, right? So who we ask is going to be important. Joey said people who don't live in America. Guess what? Americans live overseas. They're called expatriates and they vote. George, you said people who aren't registered to vote. Why don't I care about the people who aren't registered to vote? Okay, because at a certain point, they're not going to vote. Now, that changes in different states. I believe Wisconsin has same-day registration. You go to the polling place, you say, hey, I want to vote. They go, oh, well, you're not registered to vote. Here, fill this out. And they register you right then. You then fill out a provisional ballot to make sure that the things check out. And then once it is, your ballot's cast. South Carolina has a law. You have to be registered like, what, 60 days in advance? Or maybe a month in advance? So after a certain date, if you live in South Carolina and you want to vote, if you're not registered, you can't. Like, at all. Sucks to be you. So we might want to make the distinction when we're polling between people who can vote and can't vote. All right? My daughter Abigail has an opinion. Should we ask Abigail who she's going to vote for? Probably not, because she's 7, and I might break a little law when I let her vote. Just a little one. But that's okay. I routinely break little laws. Drive on the sidewalk, those sorts of things. Okay. So when we're talking about polls, we have to remember that there's going to be some error built into that poll. Because we might be asking some people who aren't going to vote, who can't vote, who say they want to vote, but in the end, you know, Tuesdays are hard. I got all the NCISs to watch on Tuesdays. All right? Election Day Marathon on USA. I got to stay home and watch the marathon. So not everybody we talk to is going to actually go out and vote. So one of the things we do is we ask you, before we ask you if you're going to vote, are you going to vote? And if you say, oh yeah, I'm going to vote, then we ask you the question. Now we might ask you the question, how likely are you to vote? I probably won't vote. Well, do you have a preference? Yeah, if I, got to vote, I'd probably vote for this person. So we can take that person's response, but we can say, well, they're not going to vote. Exclude them from our analysis. So what we have is a margin of error of, typically in surveys, it ranges from 3 to 4%. What does that mean when we talk about a margin of error? Well, they're talking about what is the range of values within usually 95% of what we think the population mean to be. Okay. So it's kind of, this margin of error is because people that compute it understand that our sample mean is taken from a much larger population of people, and we know that if we repeat the drawing of the mean, we might get different ones. We might do the exact same survey and get 46% or 42% or let's say 52%, because it's a sample. And we know, because I did the little simulation last time, we know that each of our sample means comes from a distribution that is normally shaped. And because we know what we have, we know that our mean is part of a larger distribution, we can use that same z-score methodology on our sample mean. And we can figure out how likely, that's a probability term, how likely it is that you would get a sample mean of our score from a larger distribution. Okay. So we sort of did this last time where I had the little things drop down, right? Let's say we're talking about income. If we have a known sample mean of $30,000 as a sample mean of income, let's go out and ask 1,500 people what their incomes are. Well, depending upon where you are, you might get a different answer. If you go to New York City, that mean in that area is probably going to be higher than it is out in Loris. If you go to a suburb, let's see, an expensive suburb, East Hampton, Long Island. Check the sample mean there versus, I don't know, someplace in North Dakota. Do they even have towns in North Dakota? I mean, I'm aware that some people might live there, but it's kind of spread out. No? Okay. So as we keep doing this, we keep asking and asking and asking and asking, eventually what we'll notice is that each of our samples, right, we keep doing it, keep asking and asking and asking, all of these sample means will themselves be normally distributed. Then when we remember something like our empirical rule, right, which says most of the observations are going to fall within 2 standard deviations from the mean, you go, oh, okay. So we know how likely it is that we get a sample mean from the larger distribution. Where this is going to become important for us is combining that notion of variability, like in question 14. Because we know that the true shape of the curve depends upon how variable those numbers are. So if variability is low, we know that we're going to have a single peaked curve. This was one of the questions that half of you got wrong on the homework. Right? Low variability means a high peak. Why? Because we've got to take all of that 1.0 area and squish it together. Versus high variability, which means that our 1 area is going to be able to be spread out. So it's going to be very important for us to understand when we're calculating something like our sample mean and trying to see how relative it is or how well it represents the population mean, we have to remember that variability is going to be important. So I've got one change in a name. The standard deviation becomes known as the standard error. It's just a switch in names, because now we're dealing with not a full set of data, but we're dealing of a sample mean from a big set of data. And that, the variation in our sample, is known as the standard error. And this is going to replace that standard deviation. Okay? So this is where we're headed.